Which ones do you know?
It's been on 104.7. It's been on.
Okay. Okay. Listen up, and sounds like a fun time. I probably won't be there, but I wish I could.
Always good to either
My old knees.
run or
Yeah.
show up and cheer on the runners.
Yeah, my knees and my heels just won't handle it much anymore.
You can walk.
Yeah. 3.14 miles. That would be pi miles. Okay, never mind. Okay.
I don't know if I'm into that extra 0.4.
All right. Okay. All right. Any questions on anything we've done so far? Sorry, we're not getting much of a jump on the thing. We're just barely time for class to begin now. But let's plan for the next 2 times to do 30 minutes early, and we'll count this little bit today as being the other 15 minutes that we won't do. So, all right. Any questions on anything so far? So, next week, Monday and Wednesday, try to be here at 1:30. And if I'm not here, come get me, okay? Don't leave me down there, okay? All right. Say again?
Set a timer.
Okay.
Set a timer.
My clock's batteries run out. Everything's been bad. Okay. And I left my phone charging at home. Let's see. Okay. Any questions on anything we've covered so far? Okay, we've been talking about, the title of the chapter is Exponents and Polynomials, and chapter 13, and 13.4 is going to be special topics, okay? And we're going to look at 3 of these. Square binomials, that means, no, not like that, okay? Finding the product of the sum and the difference of 2 terms, and find greater powers of binomials, okay? So let's start with square binomials. What do we mean by that? The square of a binomial, that's what they mean by it, is a trinomial. You multiply 2 binomials together. Okay, let's take this back just for a second. If these binomials are both to the first power, the first term is either the first power, second term either the first or 0th power, then this is true. If one of these is squared and, no, let's see. Okay, no, that's right. Square binomials will always produce a trinomial. Okay. Any 2 binomials you multiply won't be a trinomial necessarily, but square of a binomial will be a trinomial. Consisting of the square of the first term, here's a is the first term, square it, you get a squared. Good. Plus twice the product of the 2 terms. The 2 terms are a and b, so a times b is ab, twice that would be 2ab, right? And plus the square of the last term, plus b squared. Now, even if the second term is negative, square of the first, a squared, the product of these 2 terms would be minus ab. Twice that is minus 2ab plus b squared. Okay? So the square of binomial, here's something to watch for. The first terms are always a perfect square. The last terms are always a perfect square. And the middle term is twice the product of those square roots. That's the square of a binomial always. That binomial could have an a cubed in it and a z to the 4th power. You still do it the same way. Square a cubed, you get a to the 6th. It still works no matter what you have in there for the a and b. Does that make sense? Now, why did it jump to example 2? I didn't see example 1. Did you? Let me go back and make sure I didn't mess it some way. Well, let's see. That's not the same. So let's do example 1 in the book. Okay? Find m plus 3 squared. Let me get my pen set up. m plus 3 squared. What you reckon that would be? M squared, square the first term. Okay, 3m is the product of the two terms, and what do you do with that? Double. Yeah. Yeah. So that would be plus 6m plus 9. Okay, now, they said it, and I said it, but let me say it again. Notice the first and the last terms are always positive because they're squares. You square any number, it comes up positive. The middle term may be plus or minus, but if this is a plus, that's a plus. Then all three of them are pluses. Okay? Let's see how they did it in the book. They got it right. Good for them. Okay? All right. Now, what if you forget the rule? Is it all over then? No. If you forget the rule, m plus 3 squared means m plus 3 times m plus 3. You can go back and FOIL it, right? Binomials, easy to FOIL. What does that give you? M squared, outer, plus 3m. That's a good manufacturing company. Plus 3m, there's it doubled, right? Plus 9. And that gives you m squared plus 6m plus 9. So you don't have to remember the rule. All you have to remember is a binomial squared is a binomial multiplied by itself. Go in and FOIL it. Okay? Either way works. A lot simpler and easier if you remember the rule. But if you don't remember the rule, don't panic. You can still do the problem. Okay? Now, what's that? Okay. First up here, square the first, twice the product, square the last. 3 squared is 3 times 3. Okay, that's what it means. Squaring anything is multiplying it by itself. And down here, 3 times 3. 9 plus 9. Yeah. And it's always plus because you're squaring the last term. Whether it's positive or negative, when you square it, it comes out positive. Okay. All right, for example 1, then let's erase that, and let's square this one. Whoa, we got some numbers in here. We had one number before. How in the world would you do this? Anybody? Second? Okay, are you squaring the 4 or doubling the 4? 16x squared. Okay, square 4 is 16, square x is x squared. Next. Second? I can't hear you. 20, is that what you said? Okay, double it. 40 plus 40x. Okay, again, twice the product of the two terms. The product of them is 20x, double that, and you get 40x. And again, if you don't remember that, FOIL it. 4x plus 5 times 4x plus 5. Okay? And then finally, yeah. Was there a question? Okay. Finally, what's the last term? A little louder? Plus 25. Perfect. See how it works? And again, go back and look at them every time you double. Make sure that's a perfect square. Yeah, 16 is a perfect square, x squared is a perfect square, obviously. 25 is a perfect square. Now, that won't tell you got it all right, but at least it tells you your bookends are right. And then the middle term is twice the product of the two terms. Okay? Let's see how they did it. All right, they first treat 4x as if it was a. Ooh, let's get that writing out of there. Okay, slow down, folks. Okay, now we got it. All right. First, you treat this as an A and that's the B with a plus in between. Whoa, hold your horses. Okay. Square the first, 4x squared. Same sign. Twice the product of these two. 2 times 4x times 5. a times b, and then square the last term. Okay? Well, 4x squared is 4 squared, 16 times x squared, plus twice 4x times 5, twice 20x, or I would do it this way, if I wrote it out this way, 10 times 4 is 40x, okay? And then plus 25. Same thing we got, just carried you through a bit more rigor to get there, okay? Does it make sense? Okay? Let's try the B part. Oh, yeah, okay, sorry. I'm sorry? I still can't hear it. Sorry. Was there something distributed, you said?
No, you distribute it across.
I can't hear it.
You distribute it across like 4 different ones and do it the way it is.
You mean in here?
Yeah.
Okay, right in here. Not really a distributor, you're just multiplying 3 factors together. You can either multiply these two first, which is what we normally do, 20x, double that is 40x. Or when you write it out this way, I look at that and say, oh, 2 times 5 is 10, times 4x is 40x. To me, that's easier math than the other. They're both easy, but I just see it a lot better. Okay? But any way you do it, just be sure that you get your signs right. This is always positive, that one's always positive, and then the middle one will be the same sign as this, always. Okay? Were there other questions? Did that answer yours? I wasn't sure that it did. Okay. All right. Let's try the B one. 6x minus 2y squared. Okay? What you reckon that's going to be? Now, last time, no, I can't count on what they're going to do. Let's skip down here. Okay. What would you do first? A little louder?
36x.
36, okay. 36x squared, very good. Minus, excellent. 24. Double the 6 times 2 is 12. Double that, 24. And then you said what? XY, excellent. Okay, and then? And then? How about a sign? I need a sign. No, okay, huh? Plus 4y squared. Very good. Okay? Now, remember, this one's always positive, that one's always positive. That's why I was harping on the sign. This one's always the same as that sign. Always. Okay? Now, let's see how they did it. Any questions on how we did it? Oh, they skipped all the A's, B's, and stuff like that. They went right. Oh, now they're circling. Oh, I'm glad they did that. Okay. All right. So 6x squared minus twice the product, 2 times 6x times 2y, and then plus, always that last one is plus 2y squared. Okay? Because really it's negative 2y squared, which negative times negative is plus. So always make it a plus. Okay? So this will be 36x squared, just like we got, minus, just like we got, and then twice the product of these two. Or any way you want to multiply those together, like 2 times 12, 6 is 12, double that is 24. 2 times 2 is 4, 6 times 4 is 24, xy. There's your middle term, just like we got. And then square this, 4, square that, y squared, plus y squared. Everybody see how we got it and how they got it? Okay. Any questions? Is it fairly clear? This is how you square binomials. Now, in your future, I'm looking through a crystal ball here. I see in your future, you're going to be completing a square. You're going to do that when you learn the quadratic formula. You'll be doing that when you do lots of things later. Standard form for a quadratic function. you're going to complete a square. Okay? So you're going to do this in reverse. You're going to be given a, say, a trinomial, and then you're going to figure out what the products are. So you're going to do the same type thing we're doing now, but in reverse. So it's good to get to know this so you'll know the reverse processes to do. It will show up later. I promise. Okay? Let's do C. Oh, look at them. They skip C, D, and E. So let's us do those from the book. Okay? Let me... All right. Oops, too far. All right. Let me erase that. Now, this will be C from the book. 2a minus 9x squared. 2a minus 9x squared. What would you do for that? 4a squared. You square 2, you get 4. Square a, and you get a squared. Okay, there's your first term. Done. Okay. Minus, always get the sign. Minus 18ax. But you double it. Don't ever forget to double it. If you tend to forget that, go on and FOIL it. You'll always see it when you're FOILing it. Okay? So that would be doubled 18 is? You're leaving me hanging. 36. 36 axes. Oh, no, what is that about? Okay, never mind. Next. Plus 81 x squared. Got it. Fantastic. Does everybody see that? 4a squared plus 36ax plus minus 36ax plus 81x squared. Fantastic. Oh, and here are the ones we've been waiting for. I'm glad we went back and did these. 4m plus 1/2. We love our fractions, don't we? Squared. What are we going to do with that? Can we do that? Sure we can. It's just a number like any other number. So what would you do? 16m squared plus, got the sign right. Okay, 2m is 4m times 1/2. I'll agree with that. But double it and you get 4m. Okay. Plus. What are we doing to that? What are we doing to it? Squaring it. And squaring is multiplying it by itself. And what's 1/2 times 1/2? Second? Okay. 1/2 times 1/2. How do you multiply fractional forms? Second? I hope not. Multiply numerators. 1 times 1 is 1. Multiply denominators. 4. 1/4. Okay. I can tell some of you are skeptics and you don't believe me, do you? Try it this way. What is 1/2 as a decimal number? 0.5 times 0.5. And what does that give you? 0.25. And what is 0.25? 1/4. Okay. It must be true. I wasn't lying to you. Not too much anyway. Okay. See it? I thought we needed to brush up on our fractions, okay? This is, found you. Okay, yeah, all right. Has anyone else come in? I didn't see you come in and mark you on the roll. Okay. Okay, we're doing on section 13.4 on page 875 now. The example 2, we just finished D. We're getting ready to do E from the book. Oh my, what are they doing to us here? Okay, this is x times 4x minus 3 squared. Oh no, we've got an x in there. I don't know where to begin, or do I? Say again? You want to move the x in it first. Okay? Have you, remember good old Aunt Sally? Okay, what do we have to do with Aunt Sally? Say again? Exponents first, you're absolutely right. Don't mess with the x till you deal with the exponent. Okay, that's nice, isn't it? Okay, so let's leave the x alone for now. X times, now let's just deal with the exponential part. What does that give us? 16x squared. Everybody see that? Next. Minus, excellent. 24x. 4 times 3 is 12. Double it is 24x. Plus, always. 9. And now we multiply the last. Here's the distributing. You've been wanting to distribute all day long. Here we have one. What's that? 16x cubed minus 24x squared plus 9x. Got it. Way to go. Distribute this x across each term in your trinomial. Yes?
16x, oh, okay, I see how we got it. The 3.
Okay, yeah. Let's forget about the x for now. We're starting here. We're squaring the first term. So you square 4, 4 squared is 16, square x, x squared. Done. Then you go to the sign, bring it down. Okay? Then multiply these two together. 4 times 3 is
12.
Double it, 24. Bring down the x as well. Okay? And then we go to the last term, and because you're going to square it, that's always possible.
Okay.
And 3 squared is
9.
9. 3 times 3 is 9. Excellent. Now we distribute the x, or whatever it is out here, across the parentheses, and that will just give you 16x cubed minus 24x squared plus 9x. See it?
So, the 3, is that because we added the x? No, we're at 16. Is that cube?
Oh, this 3.
Yes.
Okay, right. We're multiplying 16x squared times x.
Okay.
Right?
Right.
Because this is a multiplication. Anything right next to a parentheses means multiply.
And that's 1.
Okay, this is x to the first times x to the second. Keep the x, add the exponents.
Okay.
Perfect, yeah. That's why here it's 1 and 1. Add those, you get 2. Here there's no x, so it's x to the 0 times x to the first, and that's x to the first. Yeah. Every one of those you multiplying by x, which raises it 1 power. Okay? Good deal. Any other questions? Great questions. All right. Let's see if the book got it. Oh, look at that. They got it right. 16x cubed minus 24x squared plus 9x. Good for them. All right. Now, here's one of these cautions. And they, oh, no, we've already been through all that. Okay, here's the caution. A common error I sort of hate for them to show you common errors. It's like, well, I like being common. No, don't be. A common error when squaring a binomial is to forget the middle term of the product. Okay? I have seen so many students in upper level classes, Math 112, 113, I'm wondering if even 125, I say, what's the square of this? Oh, that's a squared plus b squared. No, it isn't. Okay, it's nowhere close to that. You got the first term and the last term, but you can't forget the middle term. Okay? Twice the product of the two. Same thing here. This is definitely not that. Nowhere close. Okay? So don't forget. In fact, the sign of the B is wrong. Okay? So don't do that. I wish I wouldn't even show it to you. You know what I'm going to do? I'm going to do this. Okay? I'd rather you see the right thing than the wrong thing. Okay? So never just square the two and write them down. Don't forget that middle term. Okay? Got it? Okay. The second objective in this section is finding the product of the sum and the difference of two terms. Okay? Now, they're not giving you this name yet, but I'm going to give it to you now because you're going to run into it in the future. Anytime you have the sum and the difference of the same two entities, whatever they are, those are called conjugates of each other. Okay? They're similar but not quite the same. They're conjugates of each other. A plus B and A minus B are, oh, look at that. They do call them conjugates. Good for them. I just glanced in the book. I didn't see that because I don't see it in the book. Oh, there it is. It's at the very bottom. Okay. So, yeah, those are conjugates of each other. So, if we're doing that, you know, I think we can use good old FOIL, can't we? Let's do that. A plus B times A minus B. Let's FOIL it. We don't have to memorize any new formula. See, what do we get first? A times A is A squared. Then you do the outwards, and that's minus AB. And then you do the innards, and what do you get? Plus AB. And then you do the last, and you get, say again? Minus B squared. But look at those two middle terms. Whereas before, when you're squaring a binomial, you double. This time, in the middle, they add to 0. Minus AB plus AB adds to 0. So that just gives you A squared minus B squared. Now that you know that, you never have to go back and FOIL it again, but you always can if you need to. Okay? You can always go back and FOIL it. But anytime you see two conjugates multiplied to each other, square the first minus square the second. Done. Okay? Really fun stuff, right? Now, I think maybe in the next chapter, we're going to do factoring. And when you go to factor, anytime you see the difference of two perfect squares, you can just say, oh, that's the conjugates multiplied together. A plus B times A minus B. You'll be using this a lot, a whole lot. So remember that. Now, why did I say remember conjugates? Later, probably not this course, but another course, you're going to be dividing irrational numbers. And that's really hard to do unless you remember the conjugates, because you see, if one of these was irrational, like the square root of 3 and that was the square root of 3, messy. But when you multiply square root of 3 times square root of 3, you get 3. So you now made it a rational number. And you notice you don't have any middle terms, so it shows up again. So anytime you have an irrational number that you're trying to divide, that's really hard to do, multiply numerator and denominator by the conjugate, and you make dividing by a rational number, which is much easier to do. Later, you will do complex numbers, numbers that have imaginary parts in them. And it's hard to divide by an imaginary number. You don't even know what it is. But if you multiply the complex conjugate, then you get a real number again. And you can divide by real numbers anytime you want to. So you will run into conjugates at least twice in your future. I can see it now. No. Okay. So these are important things. This is just the simple ones. Oh, were you through with that? Yes, yes? Okay, got it. Okay. All right, so here's example 4. And make sure they haven't skipped anyone. And by the way, I'm doing the one on the slides. We did a few in the book. You can always go back and do the others in the book that we didn't do when I did the ones on the slide. And you got the gray ones in the margins. Please do those as well. And then your homework exercise. There's plenty of practice, right? Isn't this fun? Okay. Note they skipped example 3. So let's go back. Let's do example 3 first. We'll get to 4 in a minute. Example 3 is find each product. X plus 4 times X minus 4. What you reckon that one is? Say again? X squared. Good start. Minus what? I can't hear you. Really? You're foiling it? Oh, okay, yeah. If you're going to foil it, yeah, we'll foil it. That was your X squared, and this was your outer was minus 4X. That's perfectly legal in most states, okay? Next. Second. Plus 4X, okay. And minus 16. Okay? And then what happens? Magic happens. What happens? These two add to 0. And that gives you X squared minus 16. Which is perfectly fine to foil it. See the happy face? It's saying, yes, do it. Okay, it's fine. Or, if you wanted to, the first one squared minus the second one squared. X squared minus 16. You can jump right to the chase there if you want to. Have I told you before what makes a good mathematician? One of the things I think?
Lazy.
Yeah, you got to be a little lazy. You're always looking for the easiest way to do a problem so you don't have to work so hard. Greg Joy, he's a hard worker. He wants to foil it every time. But, you know, I'm lazier than that. I say, oh, wait, you can just multiply the conjugates together, X squared minus 16. And then I'm through and I can eat another apple or something while he's finishing his problem. Okay? I love you. Okay? So, but both ways work. Both ways are perfectly fine. Okay? That was A. Let's do B. Oh, this is why we did it. We wanted B here. 2/3 minus W times 2/3 plus W. Oh, isn't this fun? How would you do a one like that? Oh boy. I can hear the gears grinding now, okay? Say again? Not 6. 9, yes. 4/9. You got the 4 wrong too. You added them, didn't you? You're supposed to multiply them and get 4, okay? I know you. Okay, 4/9. Second? Oh, okay, you're wanting to foil it? Okay, that's fine. Plus 2/3 W. Oh, wait. Yeah. Minus 2/3 W. See, he wants to do this. That's fine. And then minus W squared. And guess what happens? Magic. Those two add to 0. Every time they're conjugates of each other. So after a while, you get tired of doing it, but not so far. Okay, what does that give you? 4/9 minus W squared. Which you could have done if you were lazy enough. Just multiply these two. 4/9 minus these two, W squared. You can skip the middle step, okay, and just go straight to the chase. If they're conjugates of each other, they have to be exactly the same two numbers with one sign different and the middle sign different. Okay? That was B. Let's do C. Oh, looks like a pattern here. X times x plus 2 times x minus 2. Now before, when it was a exponent, you always do exponents first. Now you don't have that always there. These are not exponents. You can do them any way you want to, but you have three things multiplied, but because of the associative property of multiplication, you can associate them anytime you want to, and being a good mathematician and a little bit lazy, which way do we want to do it? You could multiply these two together, and then you have to use FOIL to multiply that answer by this one. Or, to be a little lazier about it, multiply these two first. So that's just go. Don't forget the x. The x is still there. X times, and what's the product of those two? X squared minus what? Minus 4. Perfect. See how much easier that was? Now what? You're not through. Everybody see how that happened? Besides magic? Okay. X cubed, because you 1 plus 2 is 3, minus 4x. Done! Wow. Don't you like this conjugate thing? It makes that multiplying so much better. Okay? X cubed minus 4x. And the other one was 4/9 minus w squared. And, yeah, they got them all right. I'm so proud of them. Okay? Okay. Now let's erase all that. Have you got it? Everybody got it?
Yes.
Okay. No one still writing? Okay, I guess not. Okay. Now let's do example 4. Find each product. Color-coded here. What are we going to do first? I can't remember how they... Let me write this on the underneath side. Try to avoid them writing on top of me. Okay? What are you going to do first? Whoa, it didn't. Whoa. No, 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 no. My pen's not coming back. There we go. Okay. What's first? 9m squared. A little louder. Minus what? 64. You're perfect. N squared. Wait a minute. It can't be this easy, can it? It is. I've tried to think of ways to make it harder. I just can't find any way to make it harder. It's just too easy, isn't it? Well, let's see what they do. I bet you they string it out a little bit more than that. Well, they say 3m squared minus 8n squared. Yeah, that's what we did. And that's 9. Yeah, they even did it in 2 steps. Okay. You did it in 1. That's perfect. Any questions? Yes.
How come you do the other two?
What's that?
How come you do the other two to the equation?
Okay. Wait a minute. Okay.
Like the other parts of 4.
Okay, you mean foiling it? You can do it. You always can foil. But once you get tired of foiling it, you know it's always that those middle terms always cancel out if these are conjugates of each other. So after a while, you just do the square of the first. Always a minus, so plus times minus is minus. Square of the second. So it's just a shortcut. If you don't want a shortcut, foil it. You'll come up with the same answer as long as you do it correctly every time. Okay? So you choose. Long way, short way. Okay? Hard worker, lazy. You choose. Okay? All right. Now don't go and tell the dean I told you to be lazy. Okay. And not to work hard. Okay. I never said that, did I? Okay. Now. Oh, no. Don't. Whoever listens to these things anyway, huh? Hey, it's not that funny. Okay. Now, let's go to the B part. Oh, boy. They were doing this on the third one. They're doing it on the second this time. So what will this give us? Which you want to do first? Second? Okay, you want to do the last two first? Is that what you said? Okay, so that would be 2p times, and what do those give you? 25p p squared minus 1. Oh, I like ones. They're so easy, aren't they? Now what? Oh, threw a little wrinkle in, didn't they? 50 p what? Cubed. Perfect. Minus 2p. Or not 2p. No, never mind. We won't do that. Okay. Now, let's see how they did it. They did the 2p on the outside, and they wrote them as squares on the inside. That's perfectly fine if you want to take an extra step. Oh, and then they wrote on top of mine. Let me get that out of there. And that gave you 2p times 25p squared minus 1. And then distribute, and you get 50p cubed minus 2p. Got it? Just like we did, only we did it in fewer steps than they did. Does it make sense? And just if you're looking into the future again, in the future you will be factoring something like this. And in that case, you always look for common factors first. You obviously see that both terms have a p in it, so the p is going to come out. But then you say, hey, both of those are divisible by 2, so you factor out the 2p, you get up here, and then you look at that and say, hey, that's a difference of 2 perfect squared. That has to be multiply the conjugates by each other.
Come here, just make sure.
Okay.
Okay. So this is the 25p is 5 times 5.
And p times p.
And p times p
Right.
to the second power.
Right.
And then 25p to the second power times.
Okay, it's 25
Uh-huh.
times p squared.
Oh, square. Okay.
Okay. Well, I thought I heard you say it was 25p
Oh,
squared. That's not
That's
got a
not right.
parentheses in it.
Okay.
Right.
So 25p squared.
Yeah. You square this and
Uh-huh.
square that, right?
And then 25 times 2 is 50.
Right.
And then p times square is 30.
Yeah, p squared. Yeah,
P squared, okay.
Yeah.
And then minus 1 times 1 is 2.
Yeah. Up here, it's 1 times 1 is 1, so that's where the minus 1 comes from.
Uh-huh.
And then the 2p times minus 1 is minus
2.
2. Got it. Good deal.
Okay.
Okay.
Thank you.
Surely. Okay. Now, I have a feeling the slide is not going to give you a D part. I mean, a C part. The book gave you a C and a D part. I didn't even see that. I thought we went straight from B to D. Yes, they skipped them. So let's go back and let's do the C and the D. Okay? Yeah, let's do a C and a D. Here's the C part. Is Z, and this is one of our favorites again, Z minus 1/4 times Z plus 1/4. What in the world would you do with that? And don't you tell me you're going to skip it. You're going to try it, right? What would that be? Z squared. All right, we got the first part done. See, if you try something, you're going to get part of it right anyway. Z squared minus, see, you got another part right. And what's that? I can't hear. 1/16. You got it all right. Perfect. Does everybody see that? Square the first term. Z times Z is Z squared. And then anytime you're multiplying conjugates together, plus times minus is minus. Always. Minus times plus is minus. Always. Okay? So the middle, the sign is negative. And then the square fractional forms, you multiply numerators, multiply the numbers. Right? All right. Now, the D in the book was sort of like the B on the slide set, but since those are a little, actually this one has another little wrinkle in it. And we love wrinkles, don't we? That's why I don't iron my shirts. Okay. Never mind. Yeah, I didn't say that, did I? Okay. it's a 2p times p squared plus 3 times p squared minus 3. Okay? Which might you choose to do first? The conjugates, okay? Let's multiply them first. Don't forget about your 2p. It's important too. We're just not dealing with it yet. Second? P to the 4th power. You got it. Okay? What'd you say? Minus. Excellent. 9. Wow, that was easier than I thought. Now what? 2p to the 5th power minus 18p. There, you've done it. I thought that was going to be hard. Y'all did it with no sweat. You see what we do every step? Okay. Now remember, to be conjugates, these two have to be exactly the same, the signs have to be exactly opposite, and these two have to be exactly the same. If that was a p squared minus 4 times a p squared plus 3, pull it. You got to pull it. You can't do anything shortcuts on that. But if those are the same two numbers, just the only difference is the sign in between, they have to be at the same powers and everything, then you can do this shortcut. And
So the sign doesn't matter.
what's that?
The sign doesn't matter.
Well, they have to be different. That can be a minus times a plus or a plus times a minus. But they've got to be, you know, just the sign in between is the only thing that's different about it. Okay. Now, that leads to another issue. I was not going to bring it up, but since you kind of asked this, if that had said a minus p plus 3 times a plus p plus 3, then just rearrange them and it would be 3 plus p squared times 3 minus p squared. And then you do the same thing. Just say that again. A 1 every time? Is that what you said? Okay. What I was saying is one of the signs has to be different. See, and technically, both of these are pluses, but these are minuses. There are opposites. Okay. That's what I was getting at. I don't think they'll give you any like that, so don't worry about them. But somewhere in the future, some really mean-spirited book writer is going to sneak one like that in on you. Okay? Just warning you. This is a good guy, all right? Or gal, or whoever it is. Okay. Yes.
Make sure that's the 18p, is that 9 times?
Yeah. 2 times 9.
Okay.
Yeah. 2 times minus 9 is minus 18. And just bring your p down. Also, was p. P times 1 is p. Okay.
Thank you.
All right. So that was all 4 parts of example 4. Now, the last objective in this section is dealing with, let's get by all those. All right. Finding greater powers of binomials. Oh, man. Find each product, okay? In the book was x plus 5, which is a little easier, but not a lot. This is 7 minus 4s cubed. Now, if you were going to do this, why did we do it after the squaring? But we did the others in between, so don't let that confuse you, okay? How would you do this problem? What would be your first guess of a first step? Say again? Check. Say again? Okay. Here's what I'm hoping I heard you say. I'll tell you anyway. 7 minus 4s times 7 minus 4, I can't write, 4s squared. If I could have written a 4, wouldn't that be the same thing? Okay. Isn't a cubed it multiplied by it, and then just pick 2 of them together, you got a square, right? So, first step, do the square binomial. Oh, but that was at least 20 minutes ago. We've forgotten that already, haven't we? No, we haven't. Have we? Huh? Okay, let's start with this. Don't forget your first one, 7 minus 4s. Leave that alone for now. Okay? And then I heard a 49 minus 20. Wait. What did you say? Okay, 28. But you double it. One more. 56. Okay. All right. Okay. You kept going. One more. Okay. 56 what? S. Very good. Plus. Always plus. 16 S squared. You got it. Hey, way to go. Now, one reason I don't like using S as a variable, my S's sometimes look a little like 5s, and don't confuse those, okay? Probably if I typed them out, they'd be better. This slant, italicized makes it look clear. But when I write, it's sloppy, so that's why I don't like to use S's, but a lot of them do. What do we do now, though? Say again? All right. Now it's like foiling, it just has more letters. 6 letters other than 4. But you remember that. Way to go. That was even before spring break, or was that Monday? That may have been Monday. Okay. All right. So what do we do next? Oh, boy. What big numbers we have, Grandma. Okay. Say that one more time.
147.
147. I'm trying to see how you got that.
49 times
7. Okay. 7 times 9 is 63. So it better end than a 3.
343.
Oh, okay. Let's try that one. Okay, what is it?
343.
343 minus, okay, that's your first one. Okay. Next. It's a minus what?
392 S.
A little louder.
392 S.
392S. Let's see if I agree with that one. Yeah, I'll buy that one. Then the first times the last is plus 112 S squared. All right, got the first one done. Next. Okay, it's going to be a minus, and this will be an S, so I'm going to write it under there.
196.
Minus 196 S. Second times second is plus 220. Second?
224.
Yeah, 224 S squared. Excellent. And then the last, minus 64 S cubed. Now, if you're wondering how he did it so fast, he's got a calculator, okay? He's not that good. I mean, he's good, okay, but, yeah, hurts you to the core, okay. But, yes. The first one's wrong? Is that okay. 7 times 9 is 63, 6 and 28 is 34. Yeah, I think that's right.
7 times 49.
Is that what you got? Okay. Your calculator's wrong, or it was? You can't trust those little boxes. You have to, okay. All right. But we're not through yet. What do we have to do? And I wrote it like this for a purpose. Combine like terms. The only one that's just a pure number is 343 or whatever it is. Next. Oh, get out the calculators, huh? Okay. Next. They slow you down, don't they? Okay. Does it work out right?
Yeah.
just showing off, I think. Okay. Now, let's see. I guess that all makes sense. What's that?
I saw your S on the.
Oh, you thought it was a 5 again. Okay. Yeah. Oh, you got it wrong. Okay. Okay. All right. I'm real tempted to show you something now, but I'm afraid it might confuse you.
Nope.
Huh?
Don't.
Don't then. Okay. It's sort of cool, but we won't mess with it. If they were simpler numbers, I would have, but these are complicated numbers. All right. Let's see. Okay, everybody got that down? And let me go back and erase, because I know they're going right over mine. And let's see if they get the same thing. Okay? Oh, look at them. They started off the same way. 7 minus 4s times 7 minus 4s squared. Keep that 7 minus 4s by itself, and then let's do our squaring a binomial. We'll be squaring the first term twice the product of the two terms plus the square of the last term. Okay? Which becomes 7 minus 4s times 49 minus 56x, and they even got that right, okay, plus 16s squared. Okay? Now we're going to multiply term by term, and oh, they just write down the answer, don't they? Good for them, okay? And those, I think, are exactly the same numbers we had. They wrote them horizontally, which to me is a little more complicated. If they had written them vertically, they're easy to add with fewer mistakes on my part anyway. So let's see what they got. 343 minus 588s plus 336s squared minus 64s cubed. Look at that. They got it right. Now, they did it horizontally. On these type of problems, I like it vertically a little bit better. But it's still correct. Any questions on that? Does that make sense? Kind of involved, okay? Plenty of things to do there. There's 5a. Let's do, everybody got it? 5b. Okay? Okay. 2t plus 3v to the fourth power. Now, how would you suggest we do this one? Okay, that would be nice if it was legal, but I like to get two of them. That would be 2t plus 3v squared times 2t plus 3v squared. Yes. And now we can do each one of the squares separately. Then we have to do the multiplying through. Okay? But I like this way of doing it. So what's the first square? 4t squared plus what? I can't hear. How'd you get 18v? 6 doubled is 12, not tripled. Okay. That would be 12. Oh, you're on TV again? Okay. You should be doing your homework. Okay, never mind. Okay. Next. Plus 9v squared. Okay. Now guess what? The next one's the same thing, so just write it down again. 4t squared. Oh, okay, but okay. 12tv plus 9v squared. Okay? You're squaring it. Yeah, not doubling it. Doubling is multiplied by 2. Yeah. Okay. I understand what you meant. I disagree with your terminology. Okay. So now we got 3 terms to go across 3 times. So let's do the first one first. That would be 16t what? Fourth. Perfect. And then do these. And what does that give you? 48 T what? Cube V. Very good. Did everybody see that? Okay. And then the first times the third will be plus 36. Don't forget your signs in there. T squared V squared. You double TV, didn't you? No, you didn't. Okay, never mind. All right. All right. Now we're going to do the second times each of the others. So that will be this one. There's another plus 48 T cubed V, right?
Yes.
Okay. Then we do this one, plus 144 T squared V squared. And then the second times the third is plus 108 T V cubed. Oh, you're watching three TV. No, that's not what it is. Okay. Next. Okay. Will it help if I go to a different color? Maybe. Okay. Let's go to a different color. You choose a color. Second? Green? Is that what you said? Okay. I'll choose that green. Okay. So, we'll do 9V squared times 4T squared. What's that? That's, ew. I want to do this. Plus 36 T squared V squared, right? T squared V squared. Then this one will be plus 108 TV cubed. And then finally plus 81 V to the fourth. This is why I like to do it vertically, okay? You get them all lined up there, and what does that give you? 16T to the fourth, 96T cubed V, plus, oh boy, calculator time here. That 72 plus 144 is 2, say again? Okay, that's 180 plus 36 is 216. Is that right? Yeah. Oh, I got to wait on the calculator. Okay, T squared, V squared. Okay, plus 216 TV cubed, 81 V fourth. Whew! Do you see how you do that? How do you eat a 5,000-pound elephant? Like that. One bite at a time. Okay? Don't let the size of these things scare you. Just do one step at a time.
I'm afraid.
Oh, don't be afraid. Elephants don't bite. I mean, they might. They're dead anyway. Okay, never mind. All right. The meat hasn't rotted. Okay. So, there's our answer. Y'all got it down? Or are you still writing? I'll let you write. Okay. That's not the same as doubling it. Okay. No. Okay.
Write the same answer you got for the first two again.
Yeah. All right. Everybody got it, at least for now?
Yeah.
Let's see how they do it. I can't imagine how they're going to fit this on one page, but you might do it. I think they'd write over mine, so I got to erase mine. Let's see what they do. Oh, yes, they do the same thing first. That's 2V plus 2T plus 3V squared times 2T plus 3V squared. Okay, good for them. And then we know how to square a binomial. It'll be 2T squared plus twice the product of 2T times 3V plus the last one squared, 3V squared. But then do that again, okay, which is not doubling. Okay, so, okay. And then we multiply those to see what we get. This is 4T squared plus 2 times 2 is 4 times 3 is 12 TV plus this one squared is 9V squared. And then that thing again, Okay? Okay? So, at that point, we now, oh, look at them. That is not fair at all, is it? They just start writing things down. What they did was this times that is 16t fourth. This times that is 48 t cubed v. This times that is 36 t squared v squared. Then the second times each of those, these two will be that one, these two will be that one, and these two will be that one. And then the third one, 9v squared times this will be 36 t squared v squared. These two will be 108 tv cubed, and these two will be 81 v fourth. Boy, they really cheated there, didn't they? Okay. Now, what you have to do is find the like terms. That's the only one like that, so it just goes down. Then there's this one and this one. Those are the only two like that, so you add those together. This one has 3. This one and this one and that. That's why writing them vertically is easy to see. And then this one has 2, and that one has 1. Okay? And that's your answer, by the way. Not much you can do. Let's see, I think they're going to put it in block. Yeah, there they go. Oh, they combine like terms. These two combine to be this one. These 3 combine to be that one. And these 2 combine to be that one. And then that one. That's it. Same thing we got, right? Wasn't that fun? Okay. Don't answer that question. Okay. I ask other questions and I sit and it's silent. I ask out, no. Okay, no, yeah, okay. All right. That was the B part. Let's see if they do a C part. No, they don't. So let's back up and we'll do the C part. Do we have time? Yes. Okay. Here's the C part. Let me go back to dark color, okay? Okay. Negative 2r times r plus 2 cubed. How are we going to do that? Okay. Let's first just write down the negative 2r. Don't forget about it. It's going to do. And then what? R plus 2 times r plus 2 squared. Now, it doesn't matter which order you do those. I just assume do it that way. Leave the stuff not to forget about in front so you won't forget about it. Okay? Negative 2r times r plus 2. Now, you tell me what that'd be r squared. Plus 4r, don't forget your sign, plus 4. Okay, my 4s don't look very similar, but they are. Now, do you have a preference? Really doesn't matter, but yeah, let's just go on and do these two. So don't forget your minus 2r, and what you have left, r cubed, plus 4, r squared plus 4r. Then do the second. Plus 2r squared plus 8r plus 8. Okay. Now I'm going to take some time here. Minus 2r times r cubed plus what? 6r squared plus 12r plus 8. Now finally I multiply through, and what does that give us? Negative 2r to the 4th minus 12r cubed minus 24r squared minus 16r. Okay. R. Okay. Sounds like a pirate joke, doesn't it? Never mind. Okay. There's our answer. A lot of negatives in there, aren't there? Let's see what they got in the book. Minus 2r to the fourth, minus 12r cubed, minus 24r squared, minus 16r. Got it. Any questions on that? I know it's multi-step, but just take a bite at a time. Just do each step at a time. Okay? Any questions on it? All right. Now again, you have some examples in the text that we didn't do. We have all the marginal examples in the gray or whatever color that is. And then we have our exercises at the end. And let's see, let's do this concept check real quickly. The square of a binomial is a trinomial consisting of the blank of the first term. When you square a binomial, it makes a trinomial consisting of the blank of the first term. Okay, that's an inside joke. I was the straight kid in our family, okay? My younger brother was the rebel, and he had a name for me. L7. All right. That's a 7, and this is an L. What do you get? A square, because that's exactly what he thought of me, that I was a square. Okay, y'all remember that terminology? So to this day, he still calls me L. He left off the 7. Hey, L, we're adults now, 60-year-olds, and he still calls me L from L7. So it's the square, the first term squared, okay, plus blank, the blank of the two terms. Twice the product of the two terms. Excellent. Plus the blank of the last term. The square of the last term. It's been a long time, at least 40 minutes since we did it, but, less than that, I think. Number 2, in the square of a sum, all the terms are blank. Of a sum, meaning A plus B. All the terms are positive. Okay, good guess. Okay. While the square of a difference, the middle term is negative. Okay, I can't hear. Okay, number 3. The product of the sum and difference of two terms is the blank of the two terms. Ooh. Is the square of the differences of the two terms. No, the difference of the squares of the two terms. That's it, difference of the squares. And number 4, the word blank describes two expressions that represent the sum and difference of the same two numbers. You use them in radical expressions. You use them in complex expressions. Conjugate. Excellent, excellent, excellent. Okay. Do number 5. I think it's pretty easy. Okay. Do number 6. It's pretty easy. Then do any of the problems 7 through 30. Okay. A whole bunch there. They're similar to examples 1 and 2. Then do 31 and 32, and then do any that you choose from 33 to 48.
What page?
These are on pages 878, 879, and 880. Okay? So on 879, any of the ones 33 to 48, and any of the ones between 49 and 60. And then they have some fun little shapes to do, and that's 61 through 66. Okay? And then try to do 67 and or 68. And then they have some relating concepts that you did from before. Any of those would be fun to do. Okay? See what you get. And I believe we're out of time, so we'll begin next time at 3.5. Okay. Now 3.5 is the last section in this chapter, so I will try to have ready for you. I meant to have it done today, but with everybody coming by my office and stuff, I didn't get the copies made. I'll try to have a quiz for you for chapter 13, and then we'll have the test when you're through with the quiz. Okay? Good deal. Well, have a good weekend. So, strange to say that on a Wednesday, doesn't it?